Hello and welcome back to Saxon Math. This is lesson 62, writing mixed numbers as improper fractions. It's a new concept. Here's another word problem about pies. In this problem, we will change a mixed number to an improper fraction. There were 3 5/6 pies on the shelf. The restaurant manager asked the server to cut the whole pies into sixths, that is 6 equal parts. Altogether, how many slices of pie were there after the server cut the pies? So we can illustrate the problem with circles. There are 3 5/6 pies on the shelf. So you see 1, 2, 3 whole pies, and a fourth pie that only has 5 of the 6 slices remaining. The server cut the whole pies into sixths. Each whole pie then had 6 slices in it. The 3 whole pies contain 18 slices in these 3 pies. The 5 additional slices from the 5/6 of a pie bring the total to 23 sixths. This problem illustrates that 3/5 equals 23 sixths. You see that 3 5/6 equals 23 sixths. You see 3 wholes along with 5/6 is the exact same amount as 23 slices if all are distributed equally and divided into sixths. So now we describe the arithmetic for changing a mixed number such as 3 5/6 to an improper fraction. Recall that a mixed number has a whole number part and a fraction part. So when you have your whole number, you have your 3 there, and you have your fraction. That's a mixed number. The denominator of the mixed number will also be the denominator of the improper fraction. You can see here, this 6, it ended up being the denominator here as well. We can use arithmetic to determine what the numerator is going to be. So the denominator indicates the size of the fraction pieces. In this case, the fraction pieces are going to be sixths. So we change the whole number 3 into sixths. And how do we do that? Well, 3, 1, 2, 3 times 6. So you would notice that you would have 18 plus those initial 5/6 that were there, 18. So if we took 6 times 3, we get 18. And if we add that 18 plus this 5, you get 23. So once you've finished with that, you end up with 3 5/6 equaling 23 sixths, because 6/6, 6/6, and 6/6 will add up to 18 sixths plus the 5/6 that was there already as the fraction part of the mixed number. And now you have 18 plus 5 equaling 23. And then this down here, the denominator just stays the same when adding and subtracting fractions. So let's try that. Or let's look at another example here. So if you were to write 2 3/4 as an improper fraction, you simply have to take the 2 3/4. You're going to multiply the 4 times the 2, so this is times, and we're going to add whatever the answer to that is to the numerator. So this is addition here. So 4 times 2 equals 8, and 8 plus 3 equals 11. And then the denominator just stays the same. So this would be 11/4. The denominator of the fraction part of the mixed number is fourths. So the denominator of the improper fraction will also be fourths. So 2 3/4 will change into an improper fraction with a denominator of 4. We changed the whole number 2 into fourths because if you had 2 wholes and you want them to be split into 4 also, that's now 8. You have 4 times 2 is 8. So since 1 equals 4/4, the whole number 2 equals 2 times 4/4, which is the same as 8/4. And 8/4 plus this already what we have here, 3/4. So you have 8/4 plus 3/4 makes the 11/4. So your mixed number 2 and 3/4 as an improper fraction is 11/4. Those are equal to each other, 2 and 3/4 and 11/4. This is what it would look like if it was in a picture format. So if I had 2 and 3/4, here's 2 whole fourths. These two would be 1, 2. So this would be 2 wholes, and then that I could just represent that by having all these shaded in. So that's 2 whole pies there. This one is 3/4. 1, 2, 3 of them. So this would be considered 4/4. This would be 4/4. And this would be 3/4. So look at what happens if I just add those up. I've got 4 plus 4 is 8, plus 3 more makes 11. And then when you're adding and subtracting fractions, the denominator just stays the same. 11/4 is what it would be. Example 2, write 5 and 2/3 as an improper fraction. So 5 and 2/3. So again, you have to multiply the denominator with the whole number. We're going to multiply that. 3 times 5 is 15. And then we're going to take that number plus, so this 15 is what it ended up being. 3 times 5 is 15. 15 plus 2 makes 17. The denominator just stays the same, this 3. So this would be 17/3. 5 and 2/3 is the same amount as 17/3. We see that the denominator of the fraction will be thirds. So 5 and 2/3 is going to be something with a denominator of 3. Some people use a quick mechanical method to find the numerator of the improper fraction. Looking at the mixed number, they multiply the denominator by the whole number and then add the numerator. That's what I did. Multiplied the denominator by the whole number and then added the numerator. The result is the numerator of your improper fraction. So in this case, 3 times 5 is 15 plus 2 makes 17. Okay, so which method of changing a mixed number to an improper fraction do you prefer? The method in example 1 or in example 2, and why? So just think about that. So in example 1, they had us in this one basically change each of those into fractions like this and then add them together technically. So we ended up with 8/3 plus 3/4, or 8/4 plus 3/4 in that one. If we did the same thing here, we'd end up with 5 of those wholes. So 1, 2, 3, 4, 5, and then the last one is split into thirds. So it'd be like 2/3. These would all be split into thirds, each one of them. And if you were going to look at that like thirds, this would be 3/3, 3/3, 3/3. This was the example 1 method, 3/3, 3/3, and this would be 2/3. You'd have to add all those together, and you'd end up with 3, 6, 9, 12, 15, 17 in the numerator, and then the denominator just stays the same when you're adding and subtracting fractions. So 17/3, this would be like example 1. Example 2 is a mechanical way, just multiplying 3 times 5 equaling 15 plus 2 makes 17. Example 3, write 1 and 2/3 and 2 and 2/5 as improper fractions, then multiply the improper fractions. What is the product? So if you have 1 and 2/3, that's the same as 3 times 1 is 3, plus 2 makes 5/3. If you have 2 and 2/5, that's 5 times 2 is 10, plus 2 makes 12. So you have 5/3 and 12/5. And you simply multiply those straight across. You could get 60 over 15 if you want to do it that way. Or you could look at this. I like to, when I see this kind of thing, I like to cross multiply it. I recognize that 5 divided by 5 is 1 over 1. 12 divided by 3 is 4 over 1. What's that end up being in the end? 1 times 4 in the numerator, 1 times 1 in the denominator. It would equal being 4. Now, if I did it this way, if I did it the long way, if you can't recognize those relationships with those numbers being in the numerators and the denominators, you could have flipped this around. You could have said this is 12 over 3 times 5 over 5. And it's the same thing as saying, well, it's 4 times 1, because 12 divided by 3 is 4, and 5 divided by 5 is 1, and that would be 4. If you didn't recognize that and you did end up getting 60 over 15, you have to do this. You have to do 60 divided by 15, and you have to notice, well, you'd have to probably guess and check. And if I was to guess and check, I'd say, well, 3 times 10 is 30, 3 times 5 is 15, the 45 isn't enough. Then I'd take it times 4, and I'd recognize 4 times 10 is 40, 4 times 5 is 20, 40 plus that. So then I'd know now I've got 4. So, I mean, you would just end up having to do a little more work this way, unless you can see the relationship when they work together like that. All right, let's try some. Write each mixed number as an improper fraction, so 2 4/5. So if I was going to do this, I would just take 5 times 2, which is 10, and 10 plus 4 equals 14. 14 is the numerator, and 5 is the denominator. This would be the mixed number changed to an improper fraction. This is the improper fraction. Letter B, 3 1/2. This one, I'd see that 3 times 2 is 6. 6 plus 1 is 7. 7 over 2. 2 is the denominator. This would be the improper fraction. Letter C, 1 3/4. So again, doing this mechanically, I'm just looking at 4 times 1 is 4. 4 plus 3 is 7. 7 is the numerator. 4 is the denominator. This is the improper fraction. Now, if you want to check that, you could do this. 7 divided by 4. What's that? Well, 4 times 1 will get me close to 7 without going over. If I took 4 times 2, I'd be at 8. So 7 minus 4 equals 3. 3 is the numerator. 4 is the denominator. You can see 1 3/4 is 7/4, or 7 divided by 4. Letter D, 6 1/4. So again, in this one, I'm going to take 4 times 6, which is 24, plus 1, which equals 25. The denominator is a 4. Letter E, 1 5/6. This would be 6 times 1, which is 6, plus 5 makes, if you did that, I almost multiplied it. So 6 plus 5 makes 11, and the denominator just stays a 6. 6 times 1 is 6, plus 5 makes 11. Letter F, 3 3/10. Should have 10 times 3, which is 30, plus 3 makes 33. The denominator is a 10. And letter G, 2 1/3. In this one, you'd have 2 times 3 is 6, plus 1 makes 7. 7 over 3, because the denominator is already 3. 12 1/2. This would be 2 times 12, which is 24, plus 1 makes 25. And the denominator is a 2. So it's already a 2 there. Letter I, 3 1/6. This would be 3 times 6, which is 18. 18 plus 1 makes 19, and the denominator is a 6 because it's already there. And if you want to check any of these problems, all you have to do is take the numerator divided by the denominator. So 6 times 3 would get us to 18, and there'd be 1 left over. That'd be the numerator. The denominator would be that 6. So you can see it works out. Letter J, write 1 1/2 and 3 1/3 as as improper fractions, then multiply the improper fractions. What is the product? So 1 and 1/2 equals 2 times 1 plus 1. So 2 times 1 is 2, plus 1 makes 3 halves. And 3 and 1/3 is the same as 3 times 3, which is 9, plus 1 makes 10 over 3. Now I need to multiply these. So I have 3 halves times 10/3. If I was to multiply these, this would be straight across 30 over 6. So I can get 30 over 6, and most of us know what 30 divided by 6 is equal to. It equals 5. You might have also recognized this, that this 3 cancels this 3 out, or you could have reverted it to 3/3 times 10/5 or halves, and then recognized that this is the same as 1, and 10 divided by 2 is the same as 5. So in this case, though, multiplying these out, 3 times 10 gets 30, and 2 times 3 is 6. Hopefully everybody knows that. That's a simple multiplication fact. 5 times 6 is 30. 30 divided by 6 is 5. That was a pretty quick one. It wasn't that tedious. Anyway, good job. Today, make sure you work on lesson 62, questions 1 through 30. It's very important that you do all 30 math problems in Saxon math. If you do not, you are missing out on the practice required to learn the lessons. Good job, and we'll see you tomorrow.